Okay, so we are trying to find the sum of the first 100 integers. So if we see here, this is the sum of the first 100 terms in the sequence. The sequence is the sequence of integers from 1 upwards. So we have the numbers 1, 2, 3 all the way up to 100. In order to calculate this, what we do is we take the sum again and we rewrite it backwards, going from 100 down to 1. Can we see? So in order to find the sum, we're going to add these two equations together. So let's add these two equations together and we get two lots of the sum that we're after. The reason we do this is watch how they align. So if you add 1 to 100, what do we get? If you add 99 to 2, if we add 3 to 98, notice how they're all 101. So how many lots of 101 do we get? 100. Why do we have 100 lots of 101?
Because there are 100 terms in this sequence.
Do we see this? So we get 101 100 times. So the sum of 200 lots of what the sum we're after, the sum of 2 lots of what we're after, is 100 lots of 101. So the sum that we want, we just have to divide both sides by 2, and we get this. We get 100 lots of 101, divide that by 2, and we get the answer we're after. This will give us the sum of the first 100 numbers.
So it's u1 times un. My brain is not.
Let's leave that conclusion. We'll go this slow. Okay. Use the same approach to find the sum of this sequence here. Use that same technique to find the sum of this sequence here. We want to find the sum of the first 100 terms in this sequence. So find out what the last term in the sequence is first. Do this now.
So do we use this? Variation, maybe variation and maybe
Have a go at this.
I'll drive it to the first time.
My friend borrowed it and I've been asking to return it, but it sounds about back to me.
Yeah, I have a spare copy. Don't worry.
It's a very reliable friend.
He was.
Who's it?
Okay, we got the last time.
Is it Charles?
There.
Okay.
Notice what's important in the sequence. It's important to know what the last term in the sequence is. You can't do this without finding out what the last term in the sequence is, because you have to add that to the first term in the sequence. So for this sequence here, we're not given the last term, but we know that there's 100 terms, so find the last term in the sequence. We can. Yeah, you shouldn't use that. Don't use that to show that that's true. That's not correct. When you just show that one, never use the show that one. Show.
Oh, I did it! So I did it.
Right?
Plus 100 should be, you have to calculate in front of you. So that, here, I decided on that.
Yeah.
The formula, you remember the formula? This is the answer. Oh, sorry, I found the formula.
And over.
Oh my god, this is one organization.
That's new Christian's organization. So proud of
And divided by two.
Only you could okay last year.
Yeah, I wish I was good at yeah, so you remember this formula, the formula to find.
Yes.
Okay, so use that to find the last, use that to find, and that's how you, and then when you plug that in there, you should be able to.
Alright, one more minute.
Big one. This is this.
Okay, basically put it into this formula, right? So we do 3 plus 1.
What's
It's
gonna
gonna
be?
be 1. And it's
Yeah.
5
Yeah.
plus value. So we go 100 times 104 over
So,
2.
99 times 2 plus 3, which is, so it's 201.
I understand.
Here comes 100.
Use this formula to find what you 100 is.
204 times 100.
Use this formula.
No.
This
Mine is
one.
100.
Use this formula to find out what U 100 is.
Are you serious? He showed us.
Use this formula to find out what U 100 is.
Guys,
So is this?
Yeah.
I promise it's not that. Okay.
I'm sure you are wrong.
And it's 100.
What is this? And
What's the?
am I finding this?
The difference. 5
Do you know
times
what
3.
D is?
The difference.
2.
What is
Well,
it?
let me figure out what's 5 times 3. Difference. Oh, sorry.
And then what's this then?
I can't speak. Do you just talk every year?
Every November.
Okay, you do that and then you get 201. And why do you go times 2?
Because that's just the part of it. But you
So
have to
what
what
is
is
the
the
formula?
the last page.
Show that as someone. What's as someone?
And square.
That's
That's the difference. 5 times 3. That's 800.
So we found, how many
So
years we found it? What is this big It's the answer, which is 201.
So when you've got 201, how did you use it here? If you have the last term in the sequence and the first term,
So 2.
and then how many lots of that do you have?
That's very.
And then why do you divide by 2?
Is it 49?
That's it.
How did you get, you're adding these two together? So you have 2 lots of what you're after.
Yeah.
You want 1 lot of what you're after.
Oh, I did that.
Alright, okay, let's have a look now. So in order to do this, we need to find the 100th term in the sequence. We need to find the 100th term in the sequence. We're finding the 100th term in the sequence because we want the sum of 100 terms. We want the sum of 100 terms. So the sum of 100 terms is equal to the first term in the sequence. So let me do this generally. So the sum of, sorry, no. The hundredth term in the sequence is the first term in the sequence plus n minus 1 times the common difference. So this is going to be 3 plus, in order to find u100, 3 plus 100 minus 1 times 2. What do we get from this? 201? So the hundredth term in the sequence is 201. If we look what we're doing here, we take the first term in the sequence, add it to the last term in the sequence to give us this number here. We then have 100 lots of that.
Yeah.
So let's do the same. We need to do u1 plus u100, which is 3 plus 201, which is 204. To find the sum of 100 terms, we need 100 lots of that, and then divide by 2. Why are we dividing by 2?
Because when you use that formula, what you basically do is you take the last number and the first number, and you sort of like go like this, meaning you use every number twice.
So we're using every number twice because we're adding these two together. So we're getting 2 lots of the sum that we're after, not 1 lot. If we want 1 lot of the sum we're after, we divide by 2. And if we put this into our calculator, click, 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 we get this.
Yeah.
Mr. Smith,
Okay?
you have red lights or antiseptic lights?
Yeah. Let's try question 3 now.
Where can I find it?
Have a go at question 3.
Oh, yeah.
Just going to pause the video a minute.
Wait. I can do this.
Yes, you can.
I can do it really easy. Yes,
So,
it is.
I just.
Okay. So what we need to do for this one is we've got an arithmetic sequence given here. We need to figure out how many terms are in this sequence. That's our first problem. Whenever you have a show that question, never use the number in the show that question to show that. The number has to come out. So we know that the last term in the sequence is 148. The first term in the sequence is 1. We can do n minus 1 times the common difference, which is 3. If we solve this, we get n equals 50. This means there are 50 terms in the sequence. So for B now, we need to find the sum of 50 terms. This is going to be 50 lots of the first term,
Which is 1.
u1 plus
And plus 148.
u50, all over 2. So this is 50 times
1 times parentheses 1 plus 148. Divided by 2, which is 3,735.
Okay, so this process that we're doing here to find the sum of 50 terms, we're going to generalize it now. So if we want to have the sum of n terms, if we want to have the sum of n terms, how do we calculate it? What do we times first?
U of n.
What's the 50?
That's U of n, right?
No.
It's n minus.
What's the 50 here? The 100 here?
It's the number of
This 100,
the term
this
we're
is
trying to
10.
find.
It's just n.
What's this n? I mean, what's this number? It's n.
And
Oh, yeah, okay.
It's n. So we need n. We divide everything by 2. What goes inside the bracket? What goes inside the bracket?
U1 plus UN.
We need u1 plus un. We need to add the first and the last term, times it by the number of terms, divide by 2. We get this from that first calculation. We need the first and the last term, which add together to give this. We have n lots of that. And because we're adding two sums together, we get double the sum, so we divide it by 2 at the end. So the formula for the sum of an arithmetic sequence is this. Now, if we don't know what the last term in the sequence is, we can calculate it. So let me just simplify this. We'll write this as n over 2, u1 plus un. That's the formula, isn't it? If we keep this, and we keep this, but how do we calculate the nth term in a sequence? Is there a formula for it?
Yes.
Yeah.
What is the formula for the nth term in a sequence?
UN minus UN minus 1.
U1 plus
u1
1
plus
n minus 1
n minus 1 times d. How many lots of u1 do we have in this formula now?
2.
So we can add those two together, and we get 2 lots of u1 plus n minus 1 d. So if you look to your formula sheet now, you'll find that this formula here and this formula here are on your formula sheet as the sum of an arithmetic sequence. Look on your formula sheet now. It's a piece of paper in front of you. Pick it up. Find the two formulas. Formulas. We don't know necessarily because there's been a lot of vocal shifts in the last 2,000 years, so we don't know exactly how the Romans pronounce anything. There's no recording. There's just descended word of mouth, but that you get this vowel shift.
Yeah. Okay. So we can pick.
So vowels shift in languages, so it takes about 500 years, but the accents change. The vowels move across a little bit. So we get these are our two formulas. Oops, no. These are our two formulas for the sum of an arithmetic sequence. Let's have a go at using them now. Have a go at this practice question. Slipping a little last second. You're like one of those people that runs to the finish line and throws their hands up like this and then gets overtaken.
So I'm not celebrating for
Yeah, so we do not stop. We do not stop.
We do not stop.
We do not stop.
You push until you reach the 7. And when you reach a 7, you go till you get to an 8. The ID changes.
Exactly.
Yeah. Don't stop until this video stops.
You don't stop until you steal this system as well. See, Christian's like on the verge of that. New Christian.
New Christian is.
We're very proud of that.
There's actually quite a long way from where you are to where you are.
Yeah, definitely.
It's not where you start to finish.
Absolutely.
Lying in a chair, wetting yourself with no teeth.
What? Sir? That's a good.
That's only 50. No,
No.
100.
Oh,
Sure.
Surrounded by people that are waiting for you to die.
Why so morbid?
We call them
Is that
family.
virus or-
We call them family.
Dust.
So I saw this one like online discussion forum. It was like, what do you guys think really happens when we die? And like the most uploaded comment was, your family fights for your belongings.
It's worse. They take you to the second-hand store with this clip. because they don't want them.
What's the thing?
Let me pause the video.
Oh, so that's all of it.
Okay, so the first one, we need the sum of the first 20 terms in the series. We're told, we can see firstly that it's going up by -3, or it's going down by 3, consistently. This shows that it's arithmetic. So now that we know that it's arithmetic, we can find the sum of the first 20 terms using the formula n over 2, 2 times u1 plus n minus 1 times d. So this is the standard formula. Go straight to this formula if you can. And we can. So n, we want 20 terms. We need 2 lots of the first term plus 20 minus 1 times the common difference. Pop that into your calculator.
630.
630.
Yeah.
We're done. Question 2. Hey. Find the sum of the arithmetic series given here. Okay, so with this one, we have the first term, but if you have the last term, there's a shortcut. We can use the shortcut formula. So the sum of the arithmetic sequence goes like this, but we don't know how many terms are in the sequence. So we need to first find out how many terms are in the sequence. So un is equal to 90. So the last term in the sequence is 90. The first term in the sequence is 60. We don't know how many terms are in the sequence, but the common difference this time is what?
Plus 4.
Where have I got 60 from? Wrong, I'm looking at the wrong one. Minus 10.
Yeah. And then
And we're going up by 4.
difference is plus 4, yeah.
So this implies that n equals, put this into your calculator with your n solve. Try this now.
Yes. 26.
We get 26 terms in the sequence. So now we need to find the sum. We want the sum of 26 terms. We can use 26 over 2 times u1 plus un. Let me generalize the formula. We'll use the formula Sn equals n over 2 u1 plus un, which is 26 over 2 negative 10
plus 9.
plus 90,
Which is
13 times 80,
1040.
1040. B. Find the least number of terms that must be added to the series to obtain a sum greater than 100. So when we have 26 terms, we're going to get 1040. So we estimate that the answer is going to be less than 26. We need the sum to be equal to or greater than 100. So we don't know what the last term in the sequence will be this time. So let's use the sum of n terms is equal to n over 2 plus 2 lots of u1 plus n minus 1 times common difference of 4. This is going to have to be greater than 100. So n over 2 times 2 lots of u1 plus n minus 1 times the common difference has to be greater than 100. And solve this now with your calculator. And solve it with an equality. And solve it with an equal sign.
Yeah, and you just round up to the next.
What do we get for n?
So you're gonna see? Oh, I should have asked you to go back and when you actually did this time over.
No, I'd have walked over and missed the slide. If I figured it out quickly.
Yeah. You just if it's not an integer. If it is an integer, then you don't have to round up. Actually, no, you do have to round up either way because it has to be greater than 100, not equal to 100.
Can you press that?
Yeah.
We put that in.
You put n over 2 outside the decimal.
No, inside it.
Outside of the n round.
We put that in. No, equals.
Oh.
And then you go to the next one to subtract it out. It has to be greater than.
Then why is it?
Let me do this one on the calculator for you.
You get rid of your number. Yeah, I got.
Try that.
Okay, so we want to solve this inequality. We press menu, algebra, and solve. We type in our equation. We've got n over 2 multiplied by bracket 2 times bracket negative 10, close bracket, plus n minus 1, close bracket, times 4. Ooh. I'm missing a bracket actually. Nice. Okay, menu, algebra, and solve.
So could you go back over? Thank you.
N over 2 times bracket 2 times bracket negative 10 close bracket plus bracket n minus 1 close bracket times 4. Okay, scroll up, edit that. Where did I go wrong? Oh, this has to equal 100.
I somehow got my tissue.
Something's badly wrong. That seems like the right answer.
Because I did the same thing.
Yes. So can we have a negative number? No. It must be positive, mustn't it?
Yeah, because if you don't
Now, what
have
does n solve tell you?
the lowest
The lowest.
Closest to 0. So what you need to do when you get some anomaly out like this one, we have to add in a comma 0, meaning it has to be bigger than 0 that we want.
This is what I mean. So we improvise, we adapt it. We did it. I mean, you did it. I find that to be quite a lot.
So n has to be greater than
And that
10.7.
goes, let's say that.
No,
Oh,
n equals 11.
Yes. I love this.
Honestly, I thought geometric sequences were gonna be scary, but they're not.
Thank you for
Thank
These
you,
aren't
Mr.
geometric.
Same
Or are they?
No, Christian did. Christian's like in his own book. He's doing the future.
I love sigma notation. It just
So new Christian is on the questions we'll be doing in 12 days' time. New Christian is talking to us from the future.
That's only because we have like a 9-day break. So
Wait,
Okay.
so what happens when you run out of math?
You never
Runs
run
out of
out of
math.
math. For the course. You never run out of math.
He gets a 6 in comp science. So.
Okay, sigma notation. Let's have a look at this one next. So, sigma notation, I'm going to show you with a few examples because it's a little bit confusing. So, what we've got here is if we wish to add this, if we want to calculate this, the sum of 4 terms in this sequence. So, this series is 2 plus 4 plus 6 plus 8. We can use the summation symbol. Sigma here, this big E is the capital letter E from the Greek alphabet, which is sigma. It means sum. So the S sound, sigma, sum. This is where it comes from. It will add them up. Notice that we have this index variable, I. I starts off being equal to 1, and then it continues until it's 4. It goes 1, 2, 3, 4. Each time we put it into this formula, and we calculate. So let me show you the calculation. We have I equals 1 up to 4, and we have the function 2i. This is going to give us, firstly, 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4. This is going to give 2 plus 4 plus 6 plus 8, and our answer is going to be 20. Let's have a look in more detail how sigma works. So we're asked to write this expression as the sum of terms. So we have to do that expansion. Let's do the expansion. So in A, we have sigma I equals 1 up to 4, and then we have the formula 2i plus 3.
no expansion. Right?
So what is the first value of I we put in?
1.
So we take this formula, we insert a 1, and then we repeat. We add the next one. What will the new value of I be?
Oh, that's so interesting.
So we have 2 bracket 2 plus 3, and then we add the next value, which is 3, and then we add the next value.
Okay, what's the next one?
4.
Why do we stop at 4?
Because there's a 4 on top of the sigma.
Because there's a 4 on the top. Why do we start at 1?
Because it shows that I is 1. The next
I
one.
love Greek. I love Greek. Oh wait, no, I'm Turkish. I love Greek. Buffalo is Turkish.
Okay, so the first one is 2 times 1 plus 3.
5.
The second one is 2 times 2 plus 3.
7.
The next one is 2 times 3 plus 3.
9.
And the last one is 2 times 4 plus 3. So the series is 5 plus 7 plus 9 plus 11. Is this series?
Are you okay?
Yes.
Why are you dying?
Is this series arithmetic?
Yes.
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 Why?
Because
Is that
it
the
increases by
linear?
increments of 3.
It's linear. So
Of 2.
Notice it increases by increments of 2 each time. Watch this bit, Maya. Notice it goes up by 2 each time. Do we see a 2 in the formula?
Yes.
Yes.
Yeah.
So what type of formula is this one? 2i plus 3.
linear.
This is a linear. It's an ax plus b. So if you have the sum of something which is ax plus b, like this one, what is the common difference going to be?
A.
What is the first term in the sequence?
It'll be A plus B.
No.
Um,
We
Well,
don't
technically
technically
it's
say
A times I plus B.
What is the first term in this sequence here?
Oh, it is.
How do you get it from those two numbers?
You add them up. It's A plus B.
So if you have this, a equals d, the common difference,
A times
and a plus b,
Equals
U1. So U1 is equal to what? Sorry, no. B. What is B equal to?
B is equal to U1 minus A. I love when math makes sense. Do we have all of these in the formula?
Nope. You don't have any of this in the formula book.
Oh, that's why we gotta
Okay. So now we need to do B, which is to calculate this sum. So this sum is the sum of how many terms? 4. And what will it be equal to? Do 9 plus 11 first.
28
27.
plus 3 plus 12.
Take out your calculator in your hand, in your sweaty little mitts. We want to put this into the calculator. Okay?
Wait, there's a sigma symbol in the calculator.
Follow through. We press menu. Look down at your calculator, press menu. We press calculator, calculus.
So menu 4.
Menu 4, 3.
Huh? Oh my god! That is beautiful.
I want to integrate.
Oh my god!
Yeah, but you said 4, 3, but that's a CAS calculator. So you have to look down the list for sum.
Yeah, well, that's easy.
Oh my god, that is truly amazing. I was like,
Wow.
well, I was doing this yesterday. I was like, I wonder if there's a statement anywhere, but I thought it would be like in the bus. I didn't think it was going to be in the actual one. It's so weird. Oh my god.
You press the button on the keyboard that says
I think this
I.
is
Next to A, between H and J.
Stats and probability, trigonometry. I think this is going to
Sir, do you know what we're
Wait
generating?
till you get onto the financial map.
Oh, that's going to be so
Money, money, money.
Love
Teenagers love 2 things. Money. One of them is money.
Yeah.
Sir, do you know what teenagers have done with the word sigma?
Oh my
Oh no.
Sigma?
I was like,
But here the few what males are
Is it
have
like
done.
beta male?
Yeah, sigma male. Sigma male.
So you're very much a sigma.
You know, as an alpha,
Oh my god!
you come up with these things and then you tell the rest of the population to follow.
It's like
Okay,
Oh my god.
have a go at this question.
sigma notation.
Have a go at this one.
1, 2, 3, 4, 5, 6,
Sigma
no.
notation.
Sorry, 3 species. You like to try and focus and maybe you have a chance to get into a 4?
Yeah, I have a 7, 6.
Not anymore.
Yeah, I know.
No, not the other list. It would be down to a 5. Heading towards 3.
You can't do that. It's from calculation.
No,
No, it's
Yeah.
not like that.
Oh, you better find no tests. He'll do something for you.
As the king of stats, yes.
You can do whatever you want.
Yeah, no,
Sigma
wait.
male.
Have a go at writing this down. Have a go at writing this down.
Like that.
On your paper.
Common difference is 2. 2i.
One.
The 2 is to have, you have to have minus 1 because
So
adding
when I
them
can
up
read
should give
really
you
well
the
in
first
software, you know,
So
I'm
that's
like,
gonna
I'm
be
like,
minus
really gonna
one.
go away, so I should.
And then
No, you do. You should do equal
I should equal
adds
1.
on to how you would do in the unit test.
I did that. I did that. So.
Yes.
What did we
Yes.
say B signify that?
And then you have 6 terms.
For A plus
A plus B.
Good idea.
Sigma. Okay.
So B, rearrange that.
How do you try to do that?
It's not on the formula sheet. The students who paid attention will not.
I paid attention. I didn't draw it better.
You didn't. But you haven't got it in your notes. I wrote the formulas on the board on the last slide.
You know, Mr. Smith, having math today is like one of the biggest reasons I came into AISL. It's like one of the 2 classes that I really wanted to attend and see like a new topic.
That's not unusual. I've had kids come in really sick, like especially high level type guys, they come in really sick for the math class.
This is enjoyable.
And then even at the end of the lecture, they're like, can I go?
So you're even
That was before I could take lessons.
So I remember one day I came in here when I had a sprained ankle and I only came for this class and then went home and it was a class we did robots.
Ooh.
And it was very,
It was fun.
it was fun, but it wasn't as profound.
I like the class where we went outside.
I had a robot question, not a robot, a bearings question in injection 4 of the test.
Wow.
I should get it here.
Can we see it? Can we see the other classes version?
We'll use it as practice, he said.
We'll use it as practice. Okay. So, this is the formulas we're using.
It's 25.
What do we get? Sigma I equals 1. What goes on the top here?
6.
6. Why?
Because there are
Because
6
there's
terms.
6 terms.
What's the formula? What's the first part of the formula going to be?
2i.
2i.
So we have 2i. Why do we have 2?
Because it's the common difference.
And then
And
2i.
then we know that u1 has to equal the sum of A and B, and since we know that A is 2, what we can do is get 1 minus 2, which is going to equal -1. So it becomes 2i minus 1.
We do this calculation.
Yeah.
There we go. Okay. Classwork homework time.
Yeah.
Exercise 5K.